Record the meeting. Again, good evening, everyone. Okay, so without further ado, we'll try to check first the attendance as fast as we could. May I request everyone to check if you're all here and you're listening. Please try to put or chat in the chat box. Good afternoon. Again, good afternoon, everyone. Good evening. Sorry, please try to change that one. Good evening. It's already 6 o'clock. It's good evening. Good evening, everyone. Good evening. Okay, good evening. Okay. So for my case, I'm sorry, but I might go back from. I'll be trying my best to speak in English the whole time around because I guess as far as I can see, our class will be not only from the Philippines, although I'm from the Philippines. We'll be teaching also some from other nations. So I can see from Thailand and from Indonesia and so on and so forth. Okay, so some are in Japan a while ago in another set. So again, I'm hoping that you can hear me clearly. Try without further ado, we'll try to start. And we'll start first with the house rules. So may I request everyone to all throughout the meeting to kindly mute themselves unless otherwise there's something you wanted to say, but wait for me to acknowledge you first. Second, number two, kindly be attentive and feel free to interact with the class using the chat. We'll be maximizing the chat. You may type in any concerns in the chat and questions and clarification. Please don't annotate in the presentation unless you are acknowledged or if you ask me first and you are being acknowledged. So those are the 4 simple house rules that we'll be having this evening. And we'll try to discuss as much as possible all the questions today. Okay, so I again may request everyone to kindly go back to their respective position, bring your sketch papers, try to have your most comfortable seats, and let's try to start with logical thinking. The first set, again, first 6 questions are the logical thinking questions. So we will be having question number 1. Okay. Given A and B are 2 non-zero digits, and the 2 digits formed by these 2 digits of the following properties, AB is divisible by 9, and the difference between BA and a square number is 1. So find the 2-digit number AB. So I'll be giving you the time, 30 seconds to 1 minute to share answer. And after that one, we'll try to explain. So what we'll be doing try to explain for that one. Okay, again, anyone has an answer for this? Okay. If you're shy to give your answer, you can send in the chat box, direct message to me in the chat box. Okay. Yes, let's try to check. The answer is, okay, 30 seconds, 1 minute. You can share your answer. 30 seconds, 1 minute. Okay, there we go. The answer is actually 36. And I have a lot of see that the answer is 36. Now, how do we solve that one first? First things first, we need to identify your AB. Because before we can identify BA, we need to use the AB first. So AB are those numbers that are divisible by 9. So the 2-digit numbers divisible by 9 are 18. We have this one, 18, 27, 36, 45, 54, 63, 72, 81, 90, and 99. Now, if you flip them and became BA, that's 81, 72, actually the same number, but on the reversed, okay? On the reversed, except for the 99. Your AB and BA was the same. So among those number, the difference between BA and a square number is 1, okay, is 1. So actually, there are 2 possible values for this one. No? It's either actually 63 and 99. But since you use A and B are 2 digits, non-zero digits, and A and B here are different. Oh, I think there should be 2 possible answers for this one. Okay, hindi naman it did not say that the 2 digits are different from each other, so they could be the same. So we can have actually 63 because 63 is a difference between BA and a square number is 1. So we have 64 minus 63, that's 1. And we can also have 99 kasi 100 because 100 minus 99 is also equal to 1. So actually, we have two possible values of AB here, either 36 or 91. And that will become the correct 99, I mean, 99. Okay, but if the digits are different, then the only answer is 36. So there are two possible answers again, 36 and 99. Question clarification for that one. Okay, if there's none, let's try to move forward to the next question. How about this one? Peter goes west for 23 kilometers and then goes north for 12 kilometers and then goes east for 80 kilometers. Or did see from the original position right now? So that will be the next part of our situation. So again, what happened here is David went west. So here's his real position. He went west, left side, 23 kilometers, then north, like around 12 kilometers, and then uh east, like that 20 or 30 kilometers, or I mean 18 kilometers. If you'll try to look at this one, this is 23, this is 12, and this is 8. So to solve for this, basically we're trying to find right now the distance from the original position to this final position. If you look at it intently, you can see that there's a right triangle here being presented to us so that we can find the value of this position. So again, you can share your answers. Oh, 13 kilometers, 13. That's good. Okay, because again, we can actually see that this one here, this is 23. 23 minus 18, that's 5. And this is 12. For those who know Pythagorean triple, we can say that that's 13 kilometers already. But for those who don't know, we can still do with Pythagorean theorem. Okay, so looking at it, your Pythagorean theorem, let's try to move this one a little bit. Since the numbers are there, the diagram is there. Let me move it a little bit. Okay. So as you can see, okay, let's try to have that one. You can have 5 square root of 5 squared and 13 squared. You can still subtract. So 5 squared, or by Pythagorean theorem, the length will be square root of 5 squared plus 12 squared, which is 25 plus 144. Which is actually equivalent to 169. So square root of 169 is actually 13. And there you go. That's the answer to our question. Okay, question and clarification for that one, everyone, before we move forward to our next problem. Okay, I'll be giving again every other or every question I'll be letting you try to see if there's a question for that number before we move forward to our next one. Yes, none. Okay, if there's none, let's try to move forward to the next one. This one here is a little bit easy, so I'm going a little bit faster. Maybe in the harder part, going a little bit slower. Okay, so let's try to go with this one right now. Okay, how about if you do have this one? Okay, let's try to have this one. Okay, anyone? Okay. Let's try to check that one. Okay, we'll try to see. Your answer is 1,400, 142, or ooh, there's another one, 285,714. Can we have 285,714? Oh, that's an interesting one. Can we have it? 284 uh 285714. Let's try to check. So for this one, 428751. Let's try to see if that will be possible. So let's try to have this one. To solve for this, we know that uh, A, B, C, D, D, E, F are actually some addition for that number, right? So we're going to find out, okay, wait, we're trying to add up A, B, C, D, A, B, C, D, E, F, A, B, C, D, E, F, or 2 times A, B, C, D, E, F, technically, is equals to C, D, E, F, F, A, B. Right, okay. So we'll try to check your answers. Chen Kenneth, 428,571 times 2. Oh, wait. It will not coincide with the given. 285714 times 2. Double check. It's 285714. For the case of 285714, if you multiply it by 2, it will not coincide. It will become 571428, right? Did you see it? Again, let's try to clarify that one. If you have 285, what's happened to that one? For the case of 285, 285. Oh, what's happening? For the case of 285714, try to multiply it to say because you need to double check if the rule will follow. 285. Oh, 285714 times 2. That'll become 571, then 28. Okay, okay. That is a correct answer. I did see that one initially. Okay. So as you can see, it will give us the values for that one. So you can double check it, right? Okay. So as you can see, we can give or solve the situation using this kind of solution. Okay. So we can actually express. Okay, that's correct so far, right? Okay, so this is the process for that. Now, the one thing for that one for us to see is actually we need to take note of the situation here. We can try to simplify it as much as possible that it will become two-digit numbers like this one. But we can actually foresee also some problems. And how do we do that one? And how do we check the other possible values? Okay, we can actually try to do the multiples of that, right? Correct. Okay, so if you do this one here, we can express CDF because that's a part that was flipped to be 1000 or X and AB to be Y. So 1000 Y, or I mean 10,000 Y because the first 4-digit tier, the CDF tier is representing or your what we call your AB here actually represents the 10,000s place. Okay, so 10,000s AB, the 100,000s and 10,000s plus X, C times 2 is 100X because the CDF represents the 100 and Y plus Y. So if we simplify that one again, it will become 20,000 Y if you try to distribute this one. 20,000 Y if you distribute the 2. Okay. Plus 2x is equal to 100x plus y. So by transposition, that will become 19,000y. 19,999y is equal to 98x. Okay, are we clear with that one? Okay, okay, that's the case. Now, if that's the situation that we have here, we can simplify that one to be 2857y. We divide that by um we divide it by 7 both sides, and we can have 287y and equals to 14. So we can conclude that x could be 287 because of the reciprocal property and y to be 14. But multiples of that will matter also. So we can actually multiply this equation to 2, 2857 times 2. That will give us 5714 is equal to 28x. Okay. If you multiply it further by 2, it will be so far 5714 times 2 is already 5 digits. We need 4 digits for the case of x. So therefore, that's why it's another possible value. So you can also have what we call 285714. So there are two possible values for this answer, 142857 or 285714. Question and clarification for that one, everyone. Are we clear with that one, everyone? Okay, clarification question. Yes, actually. If to be safe, we can put two answers to be safe for that one. Okay, but they're asking you're trying to calculate. If you try to understand based on the question, you are trying to create the value of that. So if there are multiple values for that kind of number, you need to actually simplify all of them. Okay, so if you're calculating for the value of those numbers, again, you need to find all of them as much as possible. If there are 2 to 3 more, then you need to find that. Like solving for x, sometimes if you solve for x, you will have different values for that matter, then you need to solve all of them. So it's the same concept. So you need to solve all of them. Are we clear with that one, everyone? Okay, in the final competition, there rarely, or I think there's none actually, to be exact. There's no what we call this. There are no perfect, or I mean mistakes in the question. Also, there's no typographical error. Very rare. If there is, very rare. So more likely the questions will be properly. We multiplied it by 2, Vince. Sorry, it's a direct message. The equation was multiplied by 2, the 2857 14, because it's another multiple. We did multiply this one both sides by 2. Okay, it will still create that one, 2857 times 2, that's 5714. That's what I have said, we multiplied it by 2. 1 is equal to 2857. That's why it became like that. Are we clear with that one? You need to analyze it. If, again, as what I have said a while ago, as what I have explained, you need to check if you need a 4-digit value of x and a 2-digit value of y. So if it's times 3, as what I have shown a while ago, that's more than already, right? If you multiply it by 3, 2857, 2857 times 3 is already, oh, wait. Oh, wait. I miscalculate. 2857 times 3 is also possible. I forget that one. Because you need to find out. Okay, I did not multiply. You can actually times 3 this one also. Thank you for that. Okay, so 2857 times 3 will become 8571 is equal to 14 times 3 will be having 42. Okay, 42x and y. So meaning the other value is also 42857. So there are 3 possible values for this. Let's try to clarify that one, everyone. We do have 3 possible values for this one. We have 142857. The second one, the 285714. The last one is 428571. Okay, so we need to check. Okay, that's correct. The times 3 is also possible. Thank you for that one, Vince. Why is it limited? Or it's not limited to that one actually only. So we need to try to find, because if you try to do one more times 4, that's already more than 10,000. So we need to create 4 digits on this part of y. So therefore, these are the possible values for the value of A, B, C, D, F. So there are 3. Let me clarify. There are 3 for that one. Are we clear with this one, everyone? Question and clarification for that again? Okay, I'm so sorry. I missed that third one also. Welcome. If there's no question, let's try to move forward to the next one. We tired a little bit longer than that one. The next one is a little bit easy. Okay, for May 12, 2018 is Saturday. Which date of the week is May 12 of 2025? So for this one here, the shorter way of doing that one, but we need to clarify first. Take note that for the dates from March to December, the days is adding 2 days during the leap year. Okay, during leap years. Okay, but what I want to clarify for January to February, the +2 happen the year after leap year. Okay, it do happen the year after the leap year. So here, as you can see, May is between March to December. That's why in the leap years, it's +2 days. Meaning, if today is, let's say today is Saturday, August 20, right? August 20, Sunday. Next year, that's 2024, we are sure that August 20 is 2 days after Sunday, which is Tuesday. Because every leap year, it has add 2 for those months from March and December. So that's how we can do a little bit of a shortcut for this. So if you count how many non-leap years, there are 2021, there are 6 or 5. From 2019 to 2025, there are 5 leap years, so 5 times 1. And there are non-leap years, and there are 2 leap years, 2 times 2. So 5 plus 2, that's 9. If you divide 9 by 7, that's remainder 2. So if it's remainder 2, it means it's 2 days. Wait. 2 days after 7. Wait. 2025. Okay. So it's 2 days after Saturday. Disregard this latter part. So if it's 2 days after Saturday, that will become Monday. So Saturday, Sunday, and Monday. So the correct answer for this question is actually Monday. Question and clarification for that one, everyone, before we move forward to our next problem. Is it clear? Question, clarification, before we move forward to our next problem. Okay, there's none. Let's try to move forward to, okay, I'll be giving 30 seconds. As a while ago, some asked the question after the 30-second. Okay. Okay, let's try to move. If I can see that there's none. So if there's none, let's try to move forward to the next question. Okay, how about if you do have this one? Let's try to move forward to question number 4, I think, right? 4. Okay, the next question. Okay, there are 30 problems in a mathematics question. The scores of each problem are located with the following: 5 marks for the correct answer and 0 marks for the wrong and for the blank and wrong. So for that kind of case, now for 0 marks for blank and wrong, this is a little bit easier one, because what will we do is we just count how many possible scores, and we can easily count it to be the highest is 150. Then we have 145 for the 29, 130 or 140 minus 5 until 0. 5, then 0. So if you count that one, those are 30. 30 possible scores. There are 30 possible scores. No, 31. Forgot, because including the 0. So 31 times 3 plus 1. That will become 93 plus 1. There are 94 possible. You need to have a 94 students, so make sure that there are 4 candidates having the same score. How did it work? First things first, we need to maximize the 31 scores. Each one of them have 3, like a pigeonhole principle. Each one of them will be having 3 students having the same score. Then plus 1 for the fourth student, whatever score he can have, it's the fourth score for one of the scores there. So as you can see, the minimum number will become 94. To make sure that there will be at least one that has four scores that are the same. Okay, question clarification for that one before we continue. And question clarification for that one before we continue. Sure, that's none. Only one person is answering none. Okay, if there's no question, please do chat none for the rest. Okay, so that we can proceed forward to the next one. Okay, that's good. That's good. So that I can see that there's really no question. That if ever there is, we can consider it. Okay. If there's none, let's try to move forward to the next number. Yes, sir. Okay. Try to move forward to the next number. How about this question? Okay, this one's a little bit easy. I'll be going forward. Now the light is on. Okay, I may press the button 218 raised to 214. 2014, I mean. Can you guess whether the light is on or off for this situation? So actually it's on. Why? Because again, it's on right now. So the odd pressing a button, it will become off. So the first one is off. And the even button or the even um, number of what we call this one, the even number of turning on of the button will be on. Okay, so we know this is even. So if you have raise to an even number, it's still the answer will still become even. So therefore, even number again denotes that the light will be turned on, and therefore the answer is on for this one. Okay, question clarification for that one before we move forward to the next number. Okay. Non. If yeah, even raised to an odd is still an even number, by the way. Okay, what if there's a question to direct message or send to everyone? Even raised to an odd is still an even number. Actually, even raised to anything is still even. Odd raised to anything will be still odd. Okay, right. Even raised to an even will still be even. Odd raised to an any number, even raised to an any number is still even. Odd raised to an odd number is still odd. Or any number, I mean, is still odd. Clear for that one? Did I answer the question for that one? Even raised to zero is one. Oh, yeah, except for zero. Yeah. Thank you for that. Except for zero. Okay, because we know that a number except zero, even raised to zero is one, and even raised to what do you call this one? Even raised to um or odd raised to zero is still one. Okay, so yeah, one. Yeah. Okay, so except let's try to finish this one up. Except x should not be equal to zero. Okay, for that one. Because if it's equal to zero, it's automatically become one if you raise, except for zero raised to zero again also, because zero raised to zero will not become one. Okay, clear for that one, everyone? Hoping that was is clear for this situation. Okay, shall we continue to the next number? Okay. If that is clear, let's try to move forward to our next number. Yes. Okay. Let's try to move forward to this one. Okay, that's the first six questions. Those are all from logical thinking. Okay, now let's try to move forward to our algebra part. So we'll be going with some algebra. Okay, so some of you might have difficulty in algebra, so we'll try to see and simplify that one. Okay, so we'll try to see that one right now. And let's try to solve the following question, right? Okay, how do we do this one exactly? And how can we solve the question exactly? Okay, so for this one here, hmm, okay. Let's try to start with the very first algebra question. Okay, how about if you have this one? Oh, wait. Okay, find the value of y in this given. Okay, we'll be giving you 30 seconds, so 1 minute. Try to see the answer for that. What will be the value of y in this given? Anyone? Your y is 902. Correct. Because this one are all even values. Absolute value will never be even. So this is greater than or equal to 0. This value, the value of this one also greater than or equal to 0. So the only possible number that will have it is that both the only possible situation that they will add up to 0 if both of them will become equal to 0. So therefore, we can say that your x should be negative 901 and your y should be, by transposition, we equate them to 0. Okay, so we equate this one to 0. So by transposition, your y is actually 902. And therefore, that's the answer to our problem at hand, 902. Your y is 902. You can question and clarification for that one before we move forward to the next number. Yeah, again, question, clarification for that one before we move forward to the next number. Yes, none. Okay. Some more. If I might be some, I'll be giving you again 30 seconds to 1 minute to ask a question about that. Okay, I can see that there's none. Okay, let's try to move forward to the next number. How about this? Okay, I'll be giving 30 seconds to 1 minute to share your answer also, and maybe the question from the previous one. So how about this one? Find the value of your y also for this situation. Okay, so we'll try to find the value of your y for this one. Okay. Okay, what will be the value of your y for that one? Okay, let's try to see the solution for that. Okay, I can see a lot of answers. Okay, y. We're trying to find only y, not x. But yeah, you can solve for your x also. But here, to solve for this, we can actually do a little bit of a faster way by doing it by y. Here's what we do. We try to eliminate x. So what can we do is we multiply the first equation actually by 3, right? Multiply it by 3 like that. So you'll be having the first equation now will become 3x plus 6y is equivalent to 9, like that. Now, after that one, after we do that, we can now get the value of, or we can subtract. To eliminate 3x, we subtract the equation, so minus. So this will be canceled. 6y minus negative y will become 7y. 9 minus negative 5, that's positive 14. And therefore, your y will become equivalent to 2. And there you go. That's the answer to our problem. Y is equal to 2. Now, question and clarification for that one. And question clarification for that one. Okay, none. If there's none, let's try to move forward to the next question. How about this one? If fx and y are positive integers and 3x plus 4y is equal to 33, a linear geometry equation, we're trying to find the minimum value of x plus y. How about this one? What should be the minimum value of x plus y in this given? Okay, how about that one? Okay, what will be the minimum value of x plus y from this given? Okay, let's try to check. Okay, let's try to see and solve the problem. Okay, your answers are, let's try to check. Oh, your answers are the following, right? Okay, let's try to check those answers right now. Mhm. 9999. Okay, that's correct. The largest possible value of your x is actually equivalent to, or minimum value of x plus y is 9. How do we solve that one exactly? Now, we'll try to go a little bit of a guess and check, right? So we can actually start with either 3 or 4. So as you can see, your 4y, because uh, 4y should be greater than or equal, no, it should be less than or equal to 33. Therefore, y should be less than or equal to 33 divided by 4 is around 8 point something. So like 8.25. So we know that your y, the largest possible value of your y is 8. So we can just guess and check from that. We can use 8. You can, if y is equal to 8, there's no x. If y is equal to 7, there's no x still. If your y is equal to 6, there you go. We can have that one. Because at 24, 33 minus 24, that will become 9, right? 9. So 9 divided by 3, that will become 3. So the partnering is y is 6, x is 3. And therefore, if you add that one, that's equivalent to 9. You can double check next. As you can see, the pattern repeats. So 5 cannot have 4, and we can have 3. So if y is 3, 12, 33 minus 12, that's actually equivalent to 21 divided by 3. We get 7. So 3 plus 7 right now, that will become 10. So your x plus y will become bigger. And therefore, the minimum value that we can have so far is actually 9. So therefore, the answer to our question is 9. Are we clear with that one? It's a little bit of a guess and check linear Joe-Pantine equation, but you can see the pattern if you work on that one. Again, are we clear with that one, everyone? Before we move forward to the next next number. Okay, how about the others? Are there any questions so far? Clarification for this number? Okay, 30 seconds. Try to maximize the 30 seconds if you have any question for that. Okay, none. I can see none. Please do chat again if ever I missed your, no, your, I missed your chat as much as possible. Okay, so yeah. Okay, since there's no question, let's try to move forward to the next number. Okay, how about if we do have this situation? Okay, right. Okay, let's try to move forward to the next question. How about this one? Evaluate this expression. Okay, again, evaluate this expression. Anyone has an answer for that? Try to evaluate that expression. Again, let's try to evaluate that expression. Okay, try that one, everyone. Okay, I can see four answers. How about the rest? Are you solving also with us here for this question? Okay, we're trying to find the value 600 over 11, 54.55, 54 and 6 over 11, and so on. So you can answer actually mixed number, improper form, and even decimals. But if it's decimal, it should not be rounded off, right? So the best answer should be in fractional form if it's not, if it is extending decimal. So try to check that one. Yeah, I think 600 over 11 is also a possible answer. 54 times 11 plus 6. Yeah, 600 over or 600 over 11. Okay, so we can do that one also like that. So how do we solve that? Okay, so we can do this one like this. So since the point one are actually perfect square, that's we can actually change that one into fractional part 1 over 10, 1 over 2 over 10, 3 over 10, 10 over 10. Okay, so then after that, that will become the summation of 1 squared plus 2 squared plus that until 10 squared all over 100. So if you divide a fraction, it will flip, it will go to the numerator. That's why the 100 went here. And the summation from 1 to 20 is to n times n plus 1 over 2 again. The summation of consecutive numbers 1 plus 2 plus 3 plus 4 plus that until n is equal to n times n plus 1 over 2. And for the case of the perfect square number, 1 squared plus 2 squared plus 3 squared plus that until n squared is equal to n times n plus 1 times 2n plus 1 all over 6. So we apply the formula here, 20 times 21 over 6. Now, we don't need to multiply this one actually exactly. We can cancel out the 21 and the 10 here with the 20 and the 2 and cancel out the 20 there. And as you can see, it will become 100 times 6 all over 11, or 600 over 11, or 54 and 6 over 11. If you multiply that one, that will become a little bit more harder. So it's better for you to cancel out like that one. And that's the answer to our question. 54 and 6 over 11, or 600 over 11. Clear for that one, everyone? Before we move forward to the next number, tell me if I'm too fast in the discussion. Okay, question and clarification for that. Okay, I can see some questions. None. Oh, none. Wala. Okay, that question. Okay. But again, feel free to ask question if there is. 30 seconds is still ticking before we move forward to the next problem. Okay. All right. Okay. I think there's no question for it. Let's try to move forward to our next problem. How about if we do have this one? Okay, this one. Evaluate or find the value of 11 cube plus 12 cube until 20 cube. Summation of 11 cube, 12 cube, 13 cube until 20 cube. So what do you think will be the answer for that one, right? How about that question? What do you think will be the answer for that, right? What will be the answer for that one? So I'll be giving you time to try to answer it. Okay. Okay, I can see answers right now. I think they know what's a formula for the summation of a 1 cube until n cube. Okay. And we can apply that formula in solving this kind of problem. So let's go with that. 41075, 41075. Let's try to check if that's the correct one. It is 41,075. But how did we get that one exactly? So we have here 11 cube, 12 cube until 20 cube. Now, we don't have a formula for that one, but we do have a formula for 1 cube plus 2 cube plus 3 cube plus that until n cube. The formula for that is the square of the formula for the consecutive numbers, n times n plus 1 all over 2 quantity squared. like that. Okay, so by this time right now, you should memorize that one. So if that's the case, we can solve. So that's why what we did is we actually express everything in terms of 1 cube until 20 cube and subtract the 1 cube until 20 cube like that. So, and we can do a little bit of a shortcut for this one if you like. So this one is 20 times 20. 1 cube to 20 cube is 20 times 21 over 2 minus 10 times 11 over 2. So if you simplify this one, that's actually like that's 210 squared, right? 20 cancel out the 2, that's 10 times 21. In here, minus 55 squared. So if you want to have a faster way, you can do a plus b, a minus b. Like that will become 210 or 265, 210, sum and difference of root. So 210 plus 55 times 210, 210 minus 55, which is eventually will become 265 times 155. 265 times 155, that will become equivalent to 41,075. And yeah, that's the correct answer. 41,075. Question clarification for that one, and some shortcuts that you can do to solve it faster. What if it's just powered by 2? Again, that is only doable for perfect square numbers. I mean, perfect cube. The 1 cube plus 2 cube plus 3 cube. This formula is only applicable for 1 cube, 2 cube, and 3 cube. Yes, in terms of the technique, you can do that one still. Like you have 11 cube until 20 cube. You can subtract what we call this one. You can subtract 1 to 20 squared. I mean, 11 squared, if it's a question is 11 squared to 20 squared, you can still apply the same thought. So you can add up 1 squared to 20 squared minus 1 squared to 10 squared. Subtract, complete the expression or the set from 1 to the last one minus the missing part. And you can still do the same thing. Is that what you mean? It's a direct message, yes. Is that what you mean? Did I answer if it's squared? Welcome, welcome. But you'll be using the formula of the perfect square, which is we discussed just a while ago in the previous question. N times n plus 1 times 2n plus 1 all over 6 is the formula for the perfect square case. Okay. See, okay. Further question before we move forward to the next number. Okay, let's try to move forward to the next one. If that is the case, okay, there is none. Okay, if there's no question, let's try to move forward with this. Try to find the value. Okay, yeah. So we have to find the value of AB in this given. I'll give you 30 seconds to 1 minute to try to find the value of AB for that. Okay, how about if we do have this question? What will be the value for AB? One. Excuse me. Okay, let's check your answers for that one. Your answers are 1. Very good. Okay, some of you have shown the solution. Very good for that one. You can also share it. If you want to share it to me, that's okay also. We can have the squaring of the numbers. We know that a plus b quantity squared is equal to a squared plus 2ab plus b squared. Again, we know that a plus b is 9. So 9 squared is equivalent to, where did I get 79? So a squared plus b squared is 79. So we have 8 9 squared times 70 is equal to 79 plus 2ab. Take note that 9 squared will be on the other side. So 9 squared is 81 minus 79 is equals to 2ab. And therefore, we can say 2ab is equivalent to 2. And from that, your ab will become 1. That's the answer to our question. AB is equal to 1. Question and clarification for that one. If we move forward to our next problem. Again, question clarification. Okay, none. Okay, that's quite good if there's no question with it. Okay, if that is the case, just try to move forward to the next number. Okay, try to move forward to our next number for that one. How about if we do have this question? Okay, now, sorry, that's at 6 algebra question. So we are going with the next one. Next one will be your number theory. So 6 items again for number theory. When in the middle of the number theory question, we'll be having our break first. Okay, before so I need to rest my voice also for that one. Okay, so try to move forward with the next question. Shall we have this one? Number theory. Question number one for number theory. A three-digit number has exactly three positive factors. Find the maximum value of a three-digit number. Now, you can send your answer while I'm answering for this. So what are those numbers that have exactly three factors? Those numbers that are having exactly three factors are prime number squared. Prime squared. Okay, prime numbers squared. Those that have exactly three factors have our prime number quantity squared. So we need to take note those prime numbers. As you can see, we have 11, 13, 17, and so on. And we wanted to have a maximum of a three-digit number. So we're familiar that around 30 squared is 900 already. So we can try to check 31 and 37. So 37 is too much. It's near 40 already. It's near 1,600. So we'll be using 31. And as you can see, 31 squared, a prime number squared, is equal to 961. That's the maximum value that have exactly three positive factors. 961. Okay, it should be a prime number quantity squared. Again, are we clear with that one? Okay, so you can, if that's the case, let's try to move forward with the next number. Okay, how about this one? Okay, let's try to go with this one. Find the number of all positive factors of 830. Again, you can send your answer now. For this one, I'll be going directly with this. 830. So how do we solve the number of factors of 830? So to solve for that one, we basically do prime factorization for this. And to do the prime factorization, we are going to give the possible values. So do prime factorization of 830. That's 2 times 5 times 83. 83 is a prime. So to solve for the number of factors, we add each of the exponent by 1. Okay, so 1 plus 1, 1 plus 1, 1 plus 1, then multiply them. So that's 2 times 2 times 2, and therefore we have 8 positive factors. So that's the algorithm for that. Prime factorization and find the exponent. Add each exponent by 1 and multiply them all together. So as you can see here, it will give you 8 factors for this one. Are we clear with this one? Okay, question clarification. Okay, if there's no question, okay, none. Okay, let's try to move forward. It's a little bit easy. That's for the number of factors. You don't be confused with the number or with the, sometimes a question will be how many, the sum of the factors, but that's a little bit of a different formula. Okay, so please make sure that you remember the difference between the two. Okay, see, okay, let's try to move forward now to the next number. How about this one? How many simplified fractions with denominator 101 are there? Okay, how many simplified fractions of 101 are there? So how do we solve this one exactly? Or yeah, how do we solve this question exactly? So for this question, actually, we need to be familiar with the fact that 101 is a prime. Okay, so actually we do what we call the topient function. So if it's non-prime, this is what you will do. Topient of 101. Then you do prime factorization. That's 101. Therefore, you do prime factorization first of 101 or whatever number that you have. So if it's a little bit of different numbers, we can have prime factorization for that. But since 101 is prime, that will become 101. So topient of 101 will give us a number of simplified fractions with denominator 101. So that will become equivalent to 101 times 1 minus 1 over 101. So technically, the topient of a function or of a number will become equivalent to number times 1 minus 1 over the prime factor. Disregarding the exponent, prime factor number 1 times 1 minus 1 over prime factor number 2, and so on, until how many prime factors are there. Disregard the exponents of the prime factors. But for this case, this will become 101 times 100 over 101. So that will become 100. So there are 100 fractions, proper fractions to be exact, that are with the denominator 101 has as a fraction, simplified fractions as a fraction of 101. Question clarification for that one? Okay, question clarification for that one, everyone? Okay, if there's none, okay, let's try to move forward with our 5-minute break, 5 to 10-minute break, and we'll try to go back after the 5-minute break or after the break. See you in a while, everyone. We can have your water break and so on, and we'll try to go back to the second set, last 15 questions. let's try to the recording, and let's try to start and continue with the next one. So for the next part, the what do you call this one? The rate or the rate that we'll be having is a little bit faster from the previous one. So I'm hoping that you're here now. May I request everyone to say good evening in the chat box so that I can check that if you're here or not yet here. Okay, good evening, everyone. Let's try to move forward to the next question. Question number 16 to be exact. Again, are you here now with me? Good evening. Okay, good evening. I can see there's a lot of you already answering in the chat. Okay, so good evening again, everyone. Let's try to move forward to the next question. Okay, how about if you do have, okay, this one. Okay, let's try to have this one. According to given, we do have, okay, find the integral part of 1 over 2018 plus 2 over 2018 plus 3 over 2018 plus that until 108 over 2018. So how do we solve this one? Exactly. So to solve for this one, there's a lot of techniques. We can add up the equation divided by 2018, or we can do a little bit of the pairing up. You can pair up the first and the last. It will become 1009. So each pair will become 1009 over 2018, and that's actually 504 pairs. So all of them are actually 1/2. If you try to add that one up, that's 1009 over 2018. So that's basically 5004 times 1/2. That's 252. And that's a shorter way of how we solve that one. It could be also that the summation, no? We can do the summation 108 times 109 all over 2 divided by 2018. So we can do that one also. Okay, as you can see, we can simplify this one. That will become 504. And the 1009 divided by 2018, that's over 2. So 504 over 2. It will go back still to 252. So therefore, the integral part of this, the sum of this is an integer, is actually 202. Question clarification for that one before we move forward to our next problem. Okay, again, the rate will be a little bit faster compared to the next one. Okay, yeah, that's correct. There's none. This one is a little bit easy. Okay, if there's no question with that, let's try to move forward with the next number. Okay. Okay. Okay, let's try to move forward to the next number. Okay, next number. Find the decimal part. This time, the decimal part of these numbers. So we're adding negative numbers. Actually, we can do the same thing as what I have did a while ago. We can add up from -1 to -10. That's negative of 10 times 11 over 2. That's 55 over negative 55 over 2018. So we're trying to find the decimal part of this. So actually, I'm contemplating. No, the decimal part of this, and the negative numbers decimal part is actually subtracted from the previous number, okay? So it's actually not -1, it will become 0. So actually the best answer for this one is not 1963 over 2018. Again, we're trying to get the decimal part of that one only. So what is the definition of a decimal actually? Okay, let's try to differentiate or let's try to find the definition of the decimal part. When you see the decimal part of a number, how do we define that one? Decimal part of a number, right? Decimal part of a number is the right part. It's in the right part of your decimal point. So how about if the number is negative? How do we do the decimal part of that? No? How do we find the decimal part of a negative number? So take note that this is how will we do that one, right? So the decimal part of a negative number is being done by this. So again, you have the greatest integer part of x plus the decimal part of x is equal to the number x. So to solve for the decimal part, we'll be subtracting the number itself. Okay, the number itself by, we're going to subtract the number itself by the decimal, the x, minus the greatest integer part of the number. So what's the greatest integer part of the number right now? Here, the greatest integer part of this number is actually 0, right? The greatest integer, the number that is greater than negative 55 over 28 is 0. So that's the fractional part of x will become equivalent to x, negative 55 over 218 times or minus 0. So therefore, the answer is this. Disregarded number, the answer is negative 55 over 2018 actually. Again, the fractional part or the decimal part is equivalent to the number minus the greatest integer. So the greatest integer of that number is actually 0. So negative 55 over 2018 minus 0 is negative 55 over 2018. And that's the answer to our problem at hand. Question clarification for that one before we move forward to the next number. And question clarification before we move forward to our next number. Yes, okay, that's very good if there's none. Okay, if there's none, let's try to go with the next problem. How about if you do have this one? Okay, let's try to go with the next one. Okay, find the value of x in this given such that x is greater than or greater than 0 and x is equal to 3 cube root square root of 3 square root of 3 square root of 3. Now for this kind of problem, how will we solve this scenario? Okay, so to solve for this, this is what will we do. We're actually going to find the value of the given. Okay, so we're trying to find the value we're given. Okay, and we're going to simplify our scenario here. So how do we do that one exactly? How will we do that one exactly? So as you can see, we can actually do some substitution, right? Okay, so since x is equal to an infinity of cube root of x, cube root of x, of cube root of x, the inner part here also represents your x. That's why it became x is equal to 3 square root of x, I mean square root of x. And then we can square both sides, x squared is equal to 9x. If you do, the proper way of doing this one is actually x squared minus 9x is equal to 0. X times x minus 9 is equal to 0. And therefore, you can have either 0 or 9. But we'll take only 9 because x should not be equal to 0, greater than 0. So that's why the answer is that one, 9. Right, very good. And that will become the answer to our problem 9. Now, may I ask if there's any question and clarification in what we call the abnormality and infinity inside an infinity? Again, that's infinity inside an infinity. Okay, so any question and clarification for that? A question clarification for that one? Okay, none. If there's none, let's try to move forward to the next number. Okay, you can see that there's none for this. Okay, let's try to move forward to the next number. How about this one? So the next 6 questions is about geometry. Okay, let's try to have this one. It is known that the two sides adjacent to the right angle of the right angle polygon is in the ratio 1:3. If the length of the hypotenuse is 16, find the area of a triangle. So if you'll try to look at one, we'll try to create the right triangle here. So example, this is the right triangle. Take note that the question states that the ratio between, the ratio between the two adjacent sides to the right angle is actually 1:3. So you can represent that one to be h and 3h. And that h and 3h will become your base and height of your figure. So because the two sides are actually simultaneously the base and the height, interchangeably the base and the height, with a hypotenuse of 16. Actually, here we don't need to get the value of your h. We just need to find the value of your h squared. So as you can see, we have h squared plus 3h squared, that's 9h. So h squared plus 9h squared is 10h squared is equal to 16 squared. So h squared is equal to 25.6. Now we just need to find that one because to find the area of the triangle, we need to use base times height. So that's 1/2 of height times 3h. That will become 3/2 of h squared, which is 3/2 of 25.6, and that will become 38.4. So the correct answer for this question is 38.4. Question and clarification with that. Please to tell me if I'm too fast in the explanation. Again, question and clarification for that one. Question, clarification for that one right now. Your answer, question, none. Okay. If there's none, let's try to move forward to the next number. Okay, how about if you do have this one? Okay, let's try to have this one. Wait lang. Okay, wait natin. Let's try to move forward to the next question. How about if you do have this one? The points of a coordinate plane 2, 0, 2, 4, -6, 4, -6, 0. Find the area of the rectangle formed by those 4 points as vertices. As you can see, this become a rectangle. If you try to plot the two out, you have like the following points. 2, 0 is somewhere here, like 0.20. Let's say that 1, 1, 2. Then 2, 4, 1, 2, 3, 4. Approximation here. That's your A. This is your B. Point -6, 4, C. -6 is here. Then approximate 4 is here. That's point C. And your point D is -6, 0. So here, -6 here. 0. So that will become a rectangle with having a height, which is 4. And the base, which is can be solved by subtracting 4 minus, that's 2 minus -6, which is actually 8. So as you can see, we can find the area to be 4 times 2 minus -8, -6, that's +8. Then it'll become 4 times 8, that will become 32. So the area of the polygon or the rectangle here in this given is actually 32. Now, question and clarification for that one. Okay. Is there none for that one? Okay. Excuse me. There's none. Let's try to move forward to the next number. What is the formula? The area of the rectangle. Okay. This one is actually exactly the rectangle. So the area of the rectangle is 1/2 base times height, right? Base times height. So your height is 4. Your base is the difference between 2 and -6. So that's your base times height. And that's 32. Okay, you can do the also because these are points, you can actually do the what we call this one, the area of the shoelace method or shoelace formula. Okay, so using the determinants, you can have that one also. But here, it's already a rectangle, so you don't need that one here. But again, try to research more on the shoelace formula or the shoelace method. Okay, question, clarification for that one, everyone. Welcome, welcome. If there's no question, let's try to move forward with the next one. How about this? In the figure below, AC is perpendicular to BD and AB is perpendicular to AD. So try to put them because they're perpendicular, they're right angles here. Right angle here, and this is also AB and AD are perpendicular to each other, so right angle here. AD is to AB has a ratio square root of 3 is to 1. And CD, evaluate CD over BD. CD over BD. So how do we solve that one exactly? The recordings will be uploaded. No worries for that. And then they'll be sent to you within the week, maybe by tomorrow or later, if ever all the recordings are available. As soon as the recordings are available, they'll be sent to you. Okay, it will be sent to your email. In your email, the email that you have received this, the email for this one also, whatever email you have used, it will be uploaded to your email or sent to your email. Are we clear with that one? All the recordings will be sent to your email. Okay. Did I answer the question? It's a direct message. Yes, yes. Shall I proceed? Okay, so I'll proceed. That's again, all of the recordings where you're late, if you will not be here, all the recordings will be uploaded in your email. And the one that you have used for in this for the HKIMO. Okay, so all the details there will be given to you. Okay, now with that being said, we'll try to proceed with this. You have AC perpendicular. Now we're trying to get the value of, or the ratio of CD is to BC or CB. So how do we do that one? Okay, so here's the situation. For that, we can do what we call the Pythagorean theorem. Okay, so using the Pythagorean theorem, we can actually get BD squared because of the right triangle is equal to AD squared plus AB squared. But take note that your AD squared, AD squared is actually square root of AB. If you do cross multiplication for this, we can say that AD squared, AB square root of 3. And you square that one, that will become 3AB squared plus AB squared, that will become 4AB squared. Now, because of that, we can simplify this by finding the square root of the 2. So BD is equivalent to 2AB. Okay, no more positive negative because they're length. So we can say that BD is actually twice of AB. Okay, then because of that, AB, we can see that angle ADC is 30 degrees because of that. Because again, your AB, this is 2AB. So if you have a ratio of 2AB and one side is AB, it's automatically will become a 30-60 right triangle. So 30 here, 60 here. If that is the case, BAC will also be 30 because of the fact that because of the situation where they'll become 60, this is a right triangle again. So this part will become 30 degrees. And because of that, we can see that your AB, or let's say the height AB is opposite of 30 yung BC, that's 1/2 of AB. So your BC is 1/2 of AB. And because of that, CD will become 3/2 of AB. Since you're, okay, again, BC is 1/2 of AB right now. 1/2 AB here. So we can subtract 2AB by 1/2 AB. That will become 3/2 AB na. The CD will become 3/2 AB. And from that 3/2 AB over 1/2 AB, we can simplify that one. So CD over CB will become equivalent to 3. Okay, hoping that you followed with that one. I'll be giving you 1 minute to try to ask the question here. And how did we get CD over BC? Try to analyze first the given and the solution before we continue. Again, I know that's a little bit long, or I mean, a little bit of a lot of expression and substitution. Again, question clarification with that one. I'll give you 1 minute for this part. Maybe I'm too fast. Again, I'll be giving you 1 minute for that one. Okay, is there any question for that one? Did you hear all the explanation for this part? No question? Sure, none? None. Okay. Sure. Okay. If there's none, then let's try to move forward with the next one. This one is after that very, very hard one. With this is the next one. It's a very, very easy one. What is the sum of the exterior angles of a decagon for any polygon? The sum of all exterior angles taking one exterior angle at the same time at one time is always 360 for any polygon. The sum will always be 360 degrees. If you'll be taking one exterior angle, if there's two, then that will become 720. But here in this question, we'll be taking only one exterior angle at a time per vertex. So therefore, the sum will become 360. Again, are we clear with that one, everyone, for this situation? Yeah, that is actually a okay. That is the case. If that is the case, let's try to move forward with the next part. Okay, how about if we do have this one? For the rectangles whose side lengths are integers in centimeter and its area is 215, how many different values of perimeter can it take? So for this one, the shorter way of solving for this is we are basically find the factors of 215. So we can do prime factorization to find the number of factors and pair them up. So as you can see, 1 times 2015, 5 times 403, 13 and 155, and 31 and 65. So those are the four pairings. And therefore, those four pairings will be making the base in the height. 1, 2015, ganyan. Another one is bigger, 5 and 403, ganyan. And so on and so forth. And that will create different perimeter. And there are only four perimeters because there are four sets of that one. So the correct answer for this question is actually 4. Question and clarification for that one, everyone. I mean, question and clarification for this number. Okay. Yeah, it's a little bit easy now for the it's a little bit easy actually for that one, right? So let's try to move forward now to the next one. Oh, a bit harder, but it's not that hard, this question. So for this question, actually, we're trying to find the value of your um h. So to solve for this, since 7, 24, and 25, if you're quite familiar, that's a Pythagorean triple. But you can double check by checking if it's 7 squared plus 24 squared, it should equal to 25 squared. Yes, it's 49 plus 24 squared is actually 576. If you add that one up, that's equivalent to 625, which is 25 squared. So therefore, that's a Pythagorean triple, right angle here. Now, using that one, because that's a Pythagorean triple, we can actually find the area of the triangle using the base and the height as the two legs of the triangle, 7 times 25 over 2. But right now here, this h also represents the height in relation to the base of 25. So we can use the property of the area of the triangle, 7 times 24 over 2, to be equivalent to height times 25 over 2. So to solve for your height, we can cancel this one out, and we'll have 7 times 24. 7 times 24 is what? That's 168 over 25. We can have 168 over 25 as our h, or it's better to change it also to mixed number form. That's 6 and 18 over 25. So you can answer actually any of the two, but I do suggest to answer it in a mixed number form. Okay, you can put or actually if you can have it. Now, question clarification for this. Again, I'll be giving a little bit more time for this one. Okay. Sige. Yes, it's possible to use Heron's formula. Uh, 7 times 24 over 2. Again, yeah, it's possible to use Heron's formula. It's possible to use Heron's formula, but Heron's formula is quite longer. That's why we can use the base and height. Again, where's the second or the 7 times 24 over 2? Again, this is actually a right. We have proven that this is a right triangle. So you can actually draw this one in such as that way like this. 7, then 24. Redraw the triangle, and 25 here like that. So the area of that figure, what's the area of a triangle? Base times height over 2, right? So 7 and 24 represents the legs of the right triangle are actually automatically will become the base and the height of the triangle. So 7 times 24 over 2, that's why we have that. And that is equivalent to, using this figure here, you can refer h to be the height. Again, the height of the triangle is the line from the vertex to the base that is perpendicular to it. So we can use that one, the other formula, the other area. We can find the area also by 25, the base times the height, which is h over 2. Because they are the same triangle, we can equate their area. 7 over 24, 7 times 24 over 2, the area of the same triangle is equal to 25 times the height. Actually, in a triangle, there are 3 bases and therefore there are 3 heights also. It depends upon how you flip it. Although in elementary, what we have usually is that the base is already in the mid and below, but all the sides could become the base of the triangle actually. And you can flip that and their area will still be the same. And that's how we solve for the height. Did they answer all the questions at once? Yes, yes. That's why it's called Pythagorean triple, because it will create a Pythagorean triangle. If you know Pythagorean triples, that's better. The usual ones are the 3, 4, 5. The ratio of 3 is to 4 is to 5. The ratio of 5, 12, 17. The next 5, 5, 12, 13. The ratio of 7, 24, 25, and the usual. Those are the usual going out. But there's a lot of that. You can research on that one. Also, some other Pythagorean triples and try to be familiar. Okay. Yes, and that's hope I did answer all the question that did pop up. Heron's formula, yes, you can do it, but it's quite longer. That's why we have this one. Okay, again, question clarification for that. Okay, again, look at that one. Okay, we are a little bit longer to that part. Let's try to move forward to the next question. Here we have the last 6 questions on combinatorics. Okay, so we have the next part. So we have your combinatorics. First one. It is given that the total weight of 4 apples and 3 melons. I don't know if it's a combinatoric question. I think it's an algebra question, but yeah, pwede rin. It could be in the combinatoric one. It is given that the total weight of 4 apples and 3 lemons is 1,700. And the total weight, may request everyone to kindly not annotate unless otherwise you're being asked to do so. Okay, 3 apples and 4 melons to be 1,800. Now we're trying to get the value of the weight of 1 melon. So I think this is a little bit of actually we can do this one into what we call algebra form, no? Okay, we can do this one in algebra form. So what do I mean by that one exactly, right? So to do this one, we can actually have 4a plus okay. Try to put in a text form. Okay, so you can have 4a plus 3b. 3b is equal to 1,7, right? 1,7. 4a plus 3b is equal to 1,7. Then 4m. 4a and 3m is equal to 1,700. Also, we have 3a plus 4m to be equivalent to 1,800. 1,8. Then we can add this one up. So 7a plus 7m is equal to 7a plus 7m is equal to 3,500, right? So by dividing it by 7, a plus m is equal to 500. Okay. Now, you can actually multiply this one. If you want to solve for your a, we can multiply this, or m, we can multiply this one by 3 so that you'll have 3a plus 3m right now is equal to 1,500. And by that, we can substitute or subtract this to equation, right? We can subtract this to equation. 3a, if you subtract this to equation, that will become 3a and 3a will be canceled out. 4m minus m, that will become m. And that's 1/8 minus 1/5. And that will become 300. So the weight of the one watermelon is actually 300 grams. Okay, question clarification with that one, everyone. Yes, systems of equation, but it's part of the combinatorics. And question clarification for that one, none. Okay, if there's none, let's try to move forward to the next part. Okay, how about if we do have this one? Okay. 6 boys and 9 girls are in the class. Choose 3 boys and 3 girls to form a discussion group. How many ways can we do this one? If we're just selecting the number of boys and the number of girls from a total, we can do combinations for this. So as you can see, we can do 6 combination 3, and some other books we do it 6 combination 3 like that, times 9 combination 3, like this one. So for that case, we'll be having, okay, 6 combination 3, that'll become, what's the formula of combination, by the way? N combination R is equal to Rn factorial over n minus R factorial, R factorial. So what do we do usually is we subtract. So 6 minus 3, like the 3 factorial actually was canceled out here. That's why there's no 3 factorial anymore. Times 6 minus 3 is 3 factorial, cancel out the 3 factorial. 9 minus 3 is 6 factorial. So the 6 factorial was canceled out also here. And here we can do some cancellation. 3 times 2 times 1, that's 6. So 5 times 4, that's 20. 9 times 8 times 7, we can cancel the 3 from the 9. So that's 3. 2 and 8, that's 4. 3 times 4 times 7, that will become 84. So 20 times 84, that's 1,680. And that's the answer for that problem. Are we clear with that one? Okay, right. If there's no question with that, let's try to move forward to the next part. How about if you do have this one? A sphere 6-faced die is thrown 3 times. Find the probability the sum of the numbers obtained is 17. Okay. Now here, to get a 17, we can actually do that by adding 2 6 and 1 5. So to solve for that one, this is like the only way that we can have that one. Okay, so since it's that's actually 3 ways for that one. First die, we can have 5 6 6, 6 5 6, and 6 6 5. So that's 3 ways. In each of the ways, that's 1 out of 6. So that's technically 3 times 1 out of 6 raised to 3, because that's 1 out of 6 ways for each die to get those numbers. So that's 3 times 1 out of 6. That's 3 over. Or we can cancel out 1 here. and 2. So that's 6 times 6 times 2. That's 1 over 72. Or that's 1 over 72 ways. And that will become the answer for the question. 1 over 72. Question and clarification for that one. Before we move forward to our next problem, or last few problems. Okay, tell me if I'm too fast with this one. Okay, if there's none, none. Let's try to move forward to the next number. How about this? Andy has $29 and $10 banknotes altogether. Both 420 in total. Okay. Wait, I think that should be $10, $20, and $10. Okay. There typographical error for this one. There should be $29, $20 and $10 exactly. So we have $20 and $10 all together. So we can do this one by assuming all of them are $20. That's what we did here. So 29 times 20, that's 490 minus 420. That's 160. Okay. So 29 times 20, that's 580, right? This is 580. We assume that all of them are actually $20 banknotes. Then minus 420, that's 160. Then divided by, we subtract $20 banknotes minus $10 banknotes. It means that those excess are actually your $10 banknotes. So 160 divided by 10, there are 16 $10 banknotes. And wait, if that is the case, we are assuming that all of them are $20. So it means that's the 160 is the extra. Okay, so too much. Okay, so what happened is that we are going to have having 16 $10 banknotes for that one. Okay, so 16 are $10 and the other one, 13 are the $20. So try to check 16 times 10 plus 13 times 20. Yeah, it's 420. So correct. It's 16 $10 banknotes. Are we clear with that one, everyone? Question and clarification for that? If there's none, let's try to move forward to the second to the last question for today. Inside a 52 card poker, 2 cards are chosen. Find the probability that the sum of the numbers is obtained is 17. Okay, then we assume here that your 11, Q 12, and 13, K is 13. The king is 13, the jack is queen, and so on. So if that is the case, the only possible ways we can get 17 are 13 plus 4. We can have also 12 plus 3, no 5. We have 11 plus 6, and we do have 10 plus 7, and we have 9 plus 8. So that's actually 10 5 different ways, right? 5 different ways. So if that's the case, those 5 different ways we can actually get on the 13, okay, we can actually get 10. These are interchangeable. So let's try to assume that the first card, each one of them has 4 ways. So 4 out of 52 times the second one will be 4 out of 51. Example, we get a 13. So there are 13 ways of 13 colors or 13 parts. We have the clubs, the diamond, the heart, and the spade. And there are 4 ways also for the your 4 of 4, like that one. Times, there are 5 ways here. Okay. There are 5 ways. Either we get the 13 and 14, 12 and 5, 11, 6, 10 and 7, and 9, 8. Then times 2 because they're interchangeable. Okay, you can have 4 first, then 13, or 5 and then 12. So that's why that will become the process. And if you simplify that one, that will become equivalent to 10 times 160 divided by 52 divided by 51. That's 40 over 663. And that's the answer to that problem. Again, question clarification for that one, everyone.
Lol.
Yes. Any question? Clarification with that solution? Is there any question, Jameer? Hello. Are we clear with that one? Okay. If that is clear, let's try to move forward to the next part. Sorry for my handwriting. Next question, the last question for today, we have this. There are 47 students in grade 8, 27 and 25 students playing 27 and 25 students playing basketball and volleyball respectively. However, we don't know the number of students who like both ball games. Find the maximum number of students who don't like both ball games. Okay, don't like ball games, both ball games. So the solution for this one is a little bit of the application of the Venn diagram, right? The Venn diagram. So in application of the Venn diagram, we can actually assume that in the Venn diagram, to maximize the number of those who don't like both of them, we can actually put the 27 and the 25 inside of each other. So those who like 20, those who like volleyball, the 25 will be here. And those who like basketball will be 2 more plus 27. So 25 plus 27, the universal set is 47. So that's 27 inside the two sets. We can say that there are 20. The maximum answer, or the answer for this one is 20. That's the maximum number of students that don't like both ball games. Are we clear with that one, everyone? Question and clarification for this set, for the mock set that we have right now. Okay. If there's none, hoping that you've learned something from me, okay, and you pick up some few things for you to use in the test later on. Okay, you have one more week remaining. Have a good day, everyone. Okay, see you again next meeting, hoping that you understand our discussion. Goodbye, everyone. Welcome, welcome. Goodbye.
Thank you.
Welcome, welcome. Hoping that you learned something. Goodbye, everyone. Bye bye. Welcome, welcome.